All right. Let A be an R. R is going to be our ring, our domain actually. Be such that A squared equals A, meaning that's an idempotent. Then 1 minus A is an R, and A times 1 minus A, this is A minus A squared, which is A minus A equals 0. So since this is a domain, either A equals 0 or 1 minus A equals 0, i.e. A equals 1. So that's the first part. If A is an R and A to the n is 0 for some n, well, let's see here. This is going to be n in natural numbers. Z plus, I don't know if that includes 0 or not. I guess the only no. If this is a domain, then this cannot happen for n equals 0, because domains in a domain 0 is not 1, and if n were allowed to be 0, then you'd have like 1 to the 0 equals 0. Well, anything to the 0 is 1, and so this would have to be 1 equals 0. Anyways, so you don't have to worry about 0, because there will it cannot be the case that a to the 0 equals 0 in a domain, because that would imply 1 equals 0, which is impossible in a domain. Anyways, then some factor of A to the n is 0, so A equals 0. That's because, well, you know the whole thing about A, B equals 0 implies A equals 0 or B equals 0 in a domain. That easily extends to A1 through AN equals 0 implies A1 equals 0 or AN equals 0. One of these equals 0. It's just a simple induction argument that you could do there. And yeah, you just do it for A to the n, then one of the factors, oh, but they're all the same, it's all A. So there we go. This completes the proof.